then it's a maximum. Goes the other way around. Just a little look at your working. That's lovely. So that's, yes, this is true. What you've written here is great. Okay, because we've, yes, less than 0 maximum. That's good. Okay. Good. Okay, that's nice. Have you found where, I can't see a line of working where you've shown me where they are. I can kind of just about, but we could be a bit more rigorous there. That's lovely. Well done. Good. Just checking it with you. Great, lovely. Now I think you're kind of on the right track here, but I also want to know where the stationary points are. Which equation is going to help me find where the station? This one. So we could do that, but I'd have to keep plugging values in. Okay. What's the property of a stationary point? X is 0. It's not when x is 0, because I could then actually give you a counter example there. X is 0 at that point. Yeah, anywhere along there. Great. Okay, so which equation are you going to be able to use then? Which one is telling you about gradient? That one. Yeah, good. Okay, if we just have one more minute and we'll come back together. Much better. Well done. It's really good. And then this is nice. So now we've got to make a decision as to which one is your maximum, which one's your minimum. Okay. See if you can remember what the sign of these tell you, but if not, have a little look back and see if you can. Good. Good. Well done. That's good. Okay. Right then. 3, 2, 1. If you can all, however far you've got, can you please put your pens down? Thanks, Ben. Okay, and your full attention at the front, and we're just going to work through this, but really hammer home the key concepts. When I look at this, which word in this first part is the most important? Emily, what do you think? Normal. What does that actually tell you? Lovely. Let's build on that. Well done. Good. So it's perpendicular to... It's another line that it's perpendicular to. Ben? The tangent. Okay, so that's really good. But if we're thinking about the big picture of this, I'm going to have some curve, okay, and I'll try and make it the correct sort of reference that you've got here. We've got like -3. You with me, Harsha? Yeah. And then I've got this idea of perpendicular. So tangent, normal, perpendicular to each other. What does that mean? Maybe my first step would be. Becky? Okay, that sounds reasonable. So what did you get when you did that? Okay. How's that piece of information there going to be helpful, Nihal? Good, well done. So that actually goes through the normal as well. So what's it going to help me to find about my normal? Sully? Okay, what part of the equation? Good. Okay, so straight away, if I've got y equals mx plus c, I'm going to have something that's going to help me work this out. Okay, I haven't got anything that's going to help me with the gradient yet. What can I do to do that? I'm not asked a question. Harshant. Mm-hmm. Lovely, great, really nice. What did people get for the gradient of the normal? Becky? Good, lovely. That's really nice. So this line of working, I can have y equals a third of x plus c. What did our c end up being, Ben? Yeah, good, excellent. So if I put 0 into there, 5 into there, I'll get y equals a third x plus 5. Great, lovely. Any just comments or thoughts with that? Okay, great. So find the stationary points and determine their nature. What is always true at a stationary point? Emily. Lovely. So what would my next line of working be? So I've already got it. Not so we are going to. So I think you've confused with the next step of determining their nature. Okay. First of all, I want to find where they are. Okay. So how could I do that using that line of working? Okay. Let's see if we can help you and come back to you. Nihal? Good. So Emily, if you just stay with me, the reason why I've done that is we said at a stationary point the gradient's always 0. Okay. So instead of me giving you an x value and finding the gradient, I've told you the gradient, but I want to know where it is. Okay. And it's our old friend, the quadratic. Let's factorize it. 2x, x. What do we get when we factorized it? Go on. Minus 3n plus 1. So we should have 3 over 2 or negative 1. Okay. Now there was something exactly what Emily was going to do. Stay with me, Emily. Yeah. Sally, why do we want to differentiate it again? The second derivative is greater than 0, then it's a local minimum, and that's the nature. Great. Okay. What about what's the other half of that rule? Harshant. We've got that one. What happens if... Good. Okay. What did people find then? Which one was which? Becky? Yeah. Yeah, totally agree. So this one, when we substitute it into the second derivative, we get something that is negative. Substitute that in, we get something that's positive when we do that. What's the line of working that I've kind of really glossed over there? What have I not actually done? Nihal? I haven't actually done that, have I? So what do we get then now? What is our second derivative? Good. Okay. 4x minus 4. Okay. Apologies, you're absolutely right. Okay. Does anybody have anything they'd like to just check or Ben?
With part A, I'm not 100% sure what you're doing, the differentiating to the y by that.
Okay, so what I'm doing from here is I'm saying when x is equal to 0, I substitute that into here. That gives me a gradient of -3. Okay. That's not the gradient of the normal. What's that the gradient of?
That's the gradient of the tangent, so then you remove the minus, make it the gradient of the normal, which might get the y.
So almost, I don't just change the sign. What else? Okay, good. Lovely. Okay, team. So little recap there. Today we are going to move on and we're going to do a little bit of proof practice. I've set some questions on Google Classroom, but before we dive into that, I'm going to help you cheat on Mr. Man with me. I hear you've been doing sequences with Mr. Man. Okay? And I believe that you have got some quite cool rules. For example, oh, that's Mr. Man saying don't do my stuff. Okay, good. I believe that you've got this rule. Okay? This notation, could anybody explain to me what that means in words? A few hands. Sully, what do you think? Perfect, great. Have you proved that this is true? Really? With a box? With the block? I feel like that doesn't really have the rigour that I would expect of some further mathematicians. So we're going to do it by induction. Okay? I would like you to see for n being greater than or equal to 1, I want you to see if you can prove this by induction. Okay, off you go.